Okay, so here's video number 2. All right. So we have 2 balls. Again, A and B. You're going to have to use your imagination a little bit because I'm doing this by hand. But A and B are the same size. They're also the same height off of the ground. So object A is going to drop straight down. Object B, so velocity of B, all right, is going to travel that way. Now, not only that, we're going to say that B's initial velocity is, let's go ahead and say it's something real nice. Let's say it's like 8 meters per second. Okay. Now, its velocity must be noted that it is straight horizontal at this point. It is a directly horizontal velocity. The other thing we're going to note is that their height off the ground, so this distance right here, this height, we're going to go ahead and say that's 2 meters. Okay. So what I want to know is if object A is dropped at the exact same time that object B is launched horizontally at 8 meters per second, I want to know where will object B land. So we know object B will take some sort of path, and let's go ahead and draw this in a different color. We'll use red. Object B will take some path like this, land about here. Okay, so I want to know how far is it from here, where it was dropped from, to here when it lands. This is known as the range. All right. We will denote this in any equations with notations of delta x. All right. So what I'm really asking for here is what is the range of object B? So how do we do this? Well, the first thing we're going to do is I'm going to ask you to do something for object A. I want you to calculate for me the time it takes for object A to hit the ground. So right now, hit pause and go ahead and calculate how long it takes object A to hit the ground. Go now. Okay. To do this, you should have used some kinematic equation that we've used before. Should have used something along these lines. Now, excuse me, I'm going to go down. I'll come back up to that later. All right, so to calculate this, we probably would have used something like this. Right? Just like this. Now, the initial velocity of object A was 0, so that goes away. The displacement, how far it fell, was a negative 2 meters, all right, because that's how far it fell. It's not where it started, times 1/2 times negative 9.8 times t squared. And if you run this through the calculator, what you end up getting is a time, sorry, I'm taking a second here to get this. I get t equals 0.639 seconds. I'm going to double check on my calculator here and make sure I did not screw that up. So 1 second. Yep, double checking. This is what I get. Okay, so that's the amount of time it takes for ball A to hit the ground. Now, why does that matter? It matters because if that's how long it takes ball A to hit the ground, that's how long it's going to take ball B to hit the ground. So, ball B is going to hit the ground at the same time as ball A, because if you remember from the last video, the X and Y motion happen at the same time, but independently of each other. So B is going to fall down just at the same rate that ball A falls down. So it's going to hit the ground at the same time. So if we know that, that means that the time for B to hit the ground is also 0.639 seconds. So what we're supposed to calculate now is what is the range? How far did it move sideways? Well, in the x direction. Think back to the last video. What is the motion of the ball in the x direction? The motion of the ball in the x direction is constant. It's a constant velocity. That means the ball is moving sideways at 8 meters per second the whole time. Therefore, what we can do is just in the x direction, we can say, we can use this equation here that we've used as our very first equation. We can use average velocity as d over t. Now, what we will do in this unit, because delta d becomes a little bit ambiguous, we're going to call that delta x because to represent that we're moving in the x direction. So if we do this, we get an average velocity of 8 equals our delta x. Clear this out of here. Over 0.639. And so when we do this, let me grab the calculator real quick. We get a delta x of 5.11 meters. So the range would end up being 5.11 meters. What we're going to do is we're going to do this with a single object. So now there's no longer two objects. So this ball, we're going to say this ball is on some sort of cliff. And we're going to say that this cliff is 20 meters high. Okay. We're going to say it gets launched with some initial velocity. Again, perfectly horizontally. All right. And it will be, the initial velocity will be, let's make it fun and interesting. Let's make it nice, simple. Let's say it's 15 meters per second. All right. And what we want to do is I want to know what is the range of this ball. Or in other words, what is the delta x? Now, a couple of things here, a couple more terms, okay? This initial velocity here is what we call the launch velocity. Okay, so this is the velocity the ball is launched with. At this point, the angle of the launch is 0. It is being launched perfectly horizontal. Later, and by later I mean the next few days, we will start launching things at an angle. Right? So that's number one. Number two, the height from which it is launched will be known as the launch height. Now, in terms of math, we will consider this launch height, we will usually denote this with a delta y. Now, instead of delta d. Now, again, to indicate that it's moving in the y direction or the vertical direction. Now, be careful, launch heights are not the displacement, which was what delta y would be. Delta y would be how far the ball has moved in the vertical direction. This will always be negative, okay? Will always be less than 0. So be careful of that. Now, before we had two balls. One dropped straight down, one got launched out. And we were able to calculate that the time and air for both would be the same because they'd hit the ground at the same time. Well, we don't need two balls. We can do it with one ball. So what we can do is we can calculate the time and air by just treating ball A as if it were falling straight down. So we can just treat ball A as though it's falling straight down. So to do that, I'm going to use this equation like I did before. And of course, I am going to change my delta D. I'm not going to say delta D. I'm going to say delta Y. All right. so that everything's in the y direction. I might even say like this is v y naught or a in the y direction. I might even indicate that it's the y direction there, just so that we don't get things confused. Now, because it's being, if we're treating this as a ball, it's being dropped, what's its initial vertical velocity? If it's rolling straight sideways, that would be none. It has no vertical velocity if it's rolling straight sideways. Therefore, my delta y would be equal to 1/2, and the acceleration would just be g times t squared. So this would become my displacement. My displacement here is not 20, it's negative 20. All right, and that's going to equal 1/2 times my g, which is a negative 9.8, times t squared. All right, so we punch that into the calculator. Give me 1 second to get the calculator open here. And we get a time of 2.02 seconds. So it takes 2.02 seconds to hit the ground. That means if we need to calculate our range, the ball will be traveling for 2.02 seconds. So again, we can use this equation. And remember, I'm using x instead of d, so we avoid confusion. I'm going to scooch over to some more whiteboard here. And we get an initial velocity of 15 equals my delta x all over the time that it's spent in the air. And so delta x comes out to be right around, I think it's 30.3 is what this point will end up being. Yep, and our delta x ends up being 30.3 meters. So the range is 30.3 meters. So that is, sorry, I had to pause there. Pausing again. Got a 5-month-old. My 5-month-old decided that she was not happy that my computer was getting more attention than she was, so she threw a little bit of a fit. All right, so anyways, what you have now is a little half sheet of paper, okay, that's got a variety of these types of problems on it. You need to work through these 5 little problem, or this little half sheet of paper, and just get really good at solving all of these types of problems. This is what your lab is going to be over, and your lab is pretty much going to be tomorrow. Don't really have time to push it back much further, so you'll have to be able to do this calculation tomorrow, and you'll have to do it accurately. All right. And then because that on that lab, like I said before, there's a maximum of 25 points that you can get, but it's only worth 20. So if you can do these well, it will serve you very